Julie, please feel free to lead us.
Thank you, Man. Thank you all. It's so great to have you all here for a very interesting short evening talk with our esteemed panel. If I could see our next slide, please. If I could introduce you, so here we are. I'm going to host us for today. I'm a Director of Project-Based Learning at TEDI-London, and I will be joined by Emma, Head of Engineering at Engineers Without Borders, by Claire Gott, MBE from WSP, and by Sofia, Colaço, who will be is actually a TEDI-London alumni in the summer school. Next slide, please. So really, Earth Day today, and we really wanted to speak about one of the great global challenges of our time, climate change. We all know global warming, just warming above 2 degrees C, will put about 3 billion people at risk. We feel those impacts already, and they're becoming increasingly severe. And we also know that to keep those effects within tolerable limits, we really have to start limiting our carbon emissions and ideally achieve net zero carbon. And we do this by various means, by balancing, by sequestering, by offsetting, and there are many other ways. And, you know, engineering has a great role to play on that. And so today really, but maybe just to sort of go to the built environment as a sort of an example for that. So I don't know whether you guys would appreciate that, but a typical urban environment has about 1 million tonne of material around us, each individual. All the time. Sorry, this is a slight mix. So 1 million tonne of materials per square mile around us, about 100 tonne per person. And that particular statistic has not changed for about 100 years. And of those materials, concrete is sort of the primary construction material around us at all the time. And this concrete, made of various components, of which cement is one, contributes about 5% to the global total man-made CO2 emissions. Next slide, please. So the construction industry alone has a significant impact on the environment. So as that industry, about 50% of climate change responsibility lies in that industry, 40% of its energy use globally, and about 50% of the landfill waste that we see. And on top of that, we'll have air, water, noise pollution, and, you know, what comes with build activity, sort of a certain amount of destruction of natural habitats. Next slide, please. And then really also, so this is all the stuff we built from scratch, but we also have in the UK alone about 27 million built assets, and 70% of these we will still be using in 2050. We want to have them perform for longer, and for some of you, you might be familiar with what we call the bathtub curve. So we will now have assets which will get to the final part of this curve, so we see them actually needing to be upgraded, maintained, and looked at to make sure they remain safe. And we're doing this with increasing demand. So that means with more population in urban areas. So we're thinking about 2/3 of the world population will be living in an urban area by 2050. We'll have accelerated wear and tear, and we're also already seeing more frequent extreme weather events as well. So there is the challenge of the new build, and there's the challenge of what we do with our existing assets all around us. Next slide, please. So when we then really think about, well, you know, I've got all this material, we talked about how concrete is really one of those materials around us all the time and here to stay. Let's have a bit of a look as to what we've done. So since the 1960s, we're sustainably sourcing this particular material in engineering endeavour, and about 91% of the concrete that we use today is sustainably sourced. And CO2 emissions, the intensity of that concrete has reduced by about 9% since 2008 and about 22% since 1990. And there's, of course, lots more journey to go, as you can appreciate. Next slide, please. So really, just when we think about all of this, and again, we're just putting a lens on the built environment, and actually the speakers will be looking a bit wider than this and give you a very good overview and other thoughts and things to think about. But really, we're thinking about eco-friendly building designs, so using recycled materials or natural materials. We're thinking about extending the lifetime of our structures. We're not building so much. We're thinking about renewable energy sources, smart building layouts, trying to reduce noise, using alternative fuel sources, and of course, reducing, reusing, and recycling as much as we can. But it's not just the doing and the building, it's also all about how we operate our buildings, how efficient they are, how smart our appliances are, and how we as people living in them are making sure that we absolutely are sticking to trying to be as sustainable as possible. Next slide, please. And so then really just to finish out, and all of you will be really familiar with this, but all of those UN Sustainable Development Goals go towards that. And many of these fit with the built environment, but also fit more widely in all of the various aspects that engineering is dealing with and beyond. So really for today, and next slide, I think we're going to make a really, really good start with one of the Sustainable Development Goals. And that's all about partnerships and about talking and about really working together. So we're really delighted to come to the next slide, which is a little bit of activity for you guys. So we will be starting a little bit of a poll for you guys, which should be happening right now. So if you could quickly take part really and tell us about what do engineers need to consider when creating a solution. So that's, you know, we'll see how all of the results are coming. I love these. You know, let's see how it goes. Oh, very good. Thank you for participating. That's brilliant. It'd be really interesting to see what you guys are thinking once we've had all of the presentations and what you make of them and what your thoughts are right now. So for now, we're looking really balanced. So let's this run in the background. And let's jump right in to see our first speaker coming up. And this is Emma. And Emma is a chartered civil engineer with 6 years experience. And she's worked in the water industry in Scotland. And she is the head of engineering at Engineers Without Borders, where she's responsible for driving forward their mission, leading their work to embed globally responsible engineering. Emma, over to you.
Thanks, Julie, and thank you very much for having me today to be part of this fantastic panel discussion. I think when we're thinking about how, you know, engineering saves the world, it's, for me, not easy to positively impact someone's life. It takes a lot of creativity, it takes a lot of thought and consideration for what you're doing. And also considering the planetary implications of work, whether it's directly on something that you're producing or whether it's on a knock-on impact that, say, for example, a material that you're using is dug out of the ground somewhere else in the world, and that has an impact as well. So a lot of the work in terms of engineering has this kind of systemic impact, and being able to grapple with that and think creatively about how to create solutions is something that really is fun and high impactful, but it requires like a lot of kind of ethical understanding of kind of how we operate as engineers. It's not as simple as just focusing on the technology. Those technical skill sets are absolutely critical, but when we're thinking about what we need as engineers, it's kind of balancing that with our global responsibility skill sets, our kind of empathy and understanding how we engage people as well. So that was just a little bit of a spiel on where I see kind of engineering and saving the world. But to give you a little bit more background on myself, I was actually told by my nine, which is Welsh for grandma, to not save the world. So she asked me, please don't save the world. And the reason she did that is because when I was growing up, I was very motivated by wanting to do something meaningful with my career, with my life. And she was worried about that. She thought that that would mean I would end up in dangerous places. I might be in conflict zones or war-torn areas. I might be trying to kind of save the world, in her eyes, meant something quite specific. But what I would say is actually, when I reflect back on my career to date, is thinking that actually a lot of the work that I did had a very high impact, but in a more broad term. So it was around kind of positively impacting the world, but not necessarily through kind of frontline. Like, there's fantastic initiatives in engineering that do look at disaster relief and how to respond to emergencies that we're facing. But there's also this huge world where we have companies trying to provide water services to entire nations, communities. We have electricity systems that provide people with access to energy for the first time. We have an ability as engineers to do things in an interesting way. So I worked at Binny's for a while, so this is I'm just putting it in the chat, the company I worked for, and it's quite interesting because the description on their website is all about, well, it's water engineering, and yes, there's like pipes and valves and sewage works and hydro turbines involved, but actually the impact is around like how you can provide water services with considering the impact on our rivers. How can we make sure that, you know, sanitation is available? How do we grapple with aging infrastructure? How do we provide water services to the 12 people that live on a rural island in the north of Scotland? Kind of those creative problems are really about kind of engaging in this space and thinking the open-ended problems and actually how we meet the needs of all people and our planet leaves a lot of creativity. So I really enjoyed my time there, but then moved on to Engineers Without Borders UK. So Engineers Without Borders is a charity, and we, as you mentioned, kind of engage the engineering community to embed global responsibility into the heart of what engineering is. We're a movement and set up to serve all people and the planet better than ever before, or at least get that principle of globally responsible engineering kind of switched on and really into the core purpose of what engineering is all about. But I think that I've kind of talked around my story, but I would like to acknowledge that today we have a lot of potential in the room already. You're all here today on Earth Day, and have perspectives on what you think our profession should do and how engineering can save the world. In this quick, I've got a few minutes left, so in this quick introduction, I'd like to hear from you and potentially facilitate some cross-pollination of ideas. So I'm going to ask a series of questions and would like you all to respond in the chat box. If you're on a mobile, do try and type if you can. Don't think about it, just type. This is a safe space, kind of free flowing of ideas. Feel free to be frank and open. There's no right answer. There's no wrong answer. It's just an exploration, and don't worry too much about spelling as well, because it is really fastest finger first. So just to check this is going to work, if everybody could just say hello in the chat box, that would be great. Fantastic. Brilliant. That's great. So that's kind of easing us in. And I'll give you kind of 10 to 30 seconds, probably around 20 seconds on average, to respond to some of these questions. Okay, and I'll say ready, set, post. So compose your question, and when I say post, press enter. So first question, what inspires you about engineering? I'll give 10 seconds for this one. Ready, set, post. Okay, fantastic. Fantastic. How logical it is, making change, positive change. Fantastic. Okay, next question. How does the work that you could do in engineering, or you currently do in engineering, change people's lives? I'll give 20 seconds for this one. Okay, ready, set, post. Okay, so we've got provide quicker and better approaches, solve problems, bringing people closer to nature. That's a lovely idea. And the important kind of innovation. Fantastic. Okay, here's where it gets a little bit trickier. Approximately, how many people could your work impact? Is it single figures? Is it tens? Is it hundreds? Is it more than that? Early answer. There's again no right and wrong answer. Okay, ready, set, post. A lot, tens, hundreds of thousands, communities, total planet, more than 20 for sure. Okay, interesting. Okay, do you expect your education at work or university to help prepare you to address global challenges? This is a yes or no question. Ready, set, go. Okay, interesting. Great. Please explain your answer. Okay, 10 seconds for this one. Ready, set, post. Lifelong learning. Okay. Facilities allowing for hands-on work to give insight, to give the technical skills I need. Fantastic. Can prepare you, but it's the person on their own that makes the change. That's great. Exposure. Teaching us the basics, providing me the skills I need. Okay. Final one. If we say that doctors have a moral duty to their patients first and foremost, and if we say that lawyers have a moral duty to justice first and foremost, complete this sentence. Engineers or professionals working in engineering have a moral duty to... Five seconds left. Ready, set, post. Fantastic. Okay. So developing innovative solutions, people and planets, work does not harm anyone or anything. Fantastic. And I think one of the posts in the press says that the reason I'm here is because I'm not learning this right now. And I think that is something that we see as a trend in engineering. And is part of the reason why I work for the organisation I do, Engineers That Borders UK, because we see that trend and we see the responsibility that engineers have to impacting the world and the fact that we do have an impact on people's lives. So being able to come together and direct the change that is needed to make sure that this is a core part of what it means to be an engineer is what gets me out of bed in the morning. So our moral duty underpins engineering. It's all like that's how we save the world. Digital divide, climate justice, diversity inclusion, addressing complex problems, solving problems for the majority, not just the minority, that link to human rights and the fact that like fundamentally we believe in the equality of people around the world and they should have the dignity to live a safe and just life, but also not have our planetary boundaries impacting the generations just now or into the future. Moral principles is what ethical conduct is all about. And we really do feel that ethics kind of underpins a lot of this work as well. But I think I've gone on for too long. So I'm going to hand over to the next speaker. But thank you so much for all the interaction on the chat box and get the conversation started.
Thank you so much, Emma. That was brilliant. And I'm blown away by the great answers. So we will be cherishing those. So thank you so much. And we'll hopefully pick up on some of those when we have a bit of a panel discussion later. So I hope you're warmed up. And Emma, thank you for that. Our next speaker is Sofia. And Sofia is a mechanical engineer from the NOVA School of Science and Technology. She's a 2020 TEDI-London Summer School alumni, and she's currently working as an intern at Vistion. And today we're really delighted to have Sofia talk to us about sustainability in engineering through the eyes of a student. So Sofia, over to you.
Thank you so much, Julie. And hello, everyone. Yeah, I left university not so long ago, back in January. So I have a lot of those issues and thoughts that you guys probably still have in your minds. I started university in 2015, and at the time I only had calculus, algebra, physics. Those were the only things on my mind, and sustainability was far, far away. And it was only in my second semester when a group of friends and I decided to take part in an engineering competition. It was a 24-hour competition, a case study competition, and we had to rehabilitate a building in Almada, which is the town where I'm from. And we started with the basics, you know, what can be changed? We looked at the windows, the glass, the frame, we looked at insulation, we looked at heating and cooling, and all of that is pretty basic, you know, but what really spurred on the judges with our project was that we chose to use ivy in our construction. So we chose to do a garden in the rooftop and ivy on the side of the building. And but at the time when we first thought about it, we were like, this looks cool, you know, in futuristic projects you always see plants and glass buildings and all of that, but then we started looking at the benefits of it, and we found out how incorporating green life can promote insulation, not only against temperature but noise and even smell. In Alcântara, which is an area of Lisbon, you actually have the water factory, and its rooftop is covered in green life. And the water factory is basically just a really nice name for a water treatment plant in the middle of Lisbon. So nobody knows that it's a water treatment plant. It doesn't smell, it doesn't anything, and it looks gorgeous. But this was just one of the first projects where sustainability was a key factor in the competition. But then in engineering, I felt, as some of you felt, what am I doing really? It's just math and physics. And then you see a project here, a project there, but you really had to search for it to tackle on extracurriculars, to get involved with these kind of things. But slowly I started about in my third and my fourth year, other issues started rising up. For example, plastics in 3D printing. And, you know, everybody talks about plastics and it's like, you can't use them. We have to lower our plastic consumption. But the truth is, there are some things where we can't stop using plastic. You know, you have to make those things of a certain polymer. But the question is, how can you change the process to use less polymers, or develop a process that will require less energy consumption to make a part out of another type of plastic that will be less, it will, sorry guys, English is not my first language, but that will, use less plastic in the process. So the key point is that certain little projects started coming up throughout my degree, and it brought awareness. And I think that's a key point in your education. You're not expected to just come up with a solution spontaneously in your first year or in your second year. It's an evolving process of gaining awareness and sensibility with what you're studying. And it was around in my fourth year where I did an internship at a water utility service. And my mind was just blown away. I kept thinking, how do you know of certain issues since the 1970s, and how come you haven't done a single thing about it? And don't get me wrong, the Portuguese water utility service are some of the world's exemplary water utility service, such as the ones in the UK, the ones in the Netherlands. You know, you have people in the International Water Association that are speakers there with exemplary projects. But this happens all over the world. And there were so many little issues that nobody had even tackled. And I started questioning them as a mechanical engineer. And a lot of people think, but a mechanical engineer in a water utility service, yeah, there are pumps, yeah, there's this, there's that. But I started tackling water leakage issues, and that's eventually where I did my thesis on. And it was just a continuing process of little things that brought me where I am right now, even though I'm working in electronics right now, but I hope to get back to water. Because in my view as a student, it's like going to the gym. If you're starting to work out, you're not going to start 5 days a week all at once. You're gonna want to start 2 days a week. You're gonna start to get used to it, and then you're gonna evolve. And the sustainable process is exactly like that. 50 years ago, people didn't think about most of the things that we find trivial today, you know? And we have to start making sustainable decisions so that in 10 years, 20 years, those decisions will become trivial, and then someone else can build upon. You know, we don't need to save the world with a big decision. It's the little steps. We have to think collectively. You know, someone will pick up on our work and build upon a little bit more, and then someone else will do the same. So as students, don't be anxious, don't be mad, you know, do your best, think about the little things. Don't try to grow up too fast and learn too many things at once. Things will come to you. if you just keep an open mind. And I hope you also keep an open mind towards water, because water is used in about 90% of the industries. And we think about closing the tap at home, but we don't think about the thousands and thousands of liters that are being used in the food industry, in the textile industry, in the manufacturing industry. Water is used everywhere. And I hope that in whatever area you choose to work on, that you know that if you make a decision just to reduce a water in a process, that will be a world-changing decision, because you will be changing the water that's going to be used for the next 30, 40 years that people have been wasting for the last 100. So keep an open mind. This is my advice to you as a student. Keep an open mind, gain awareness slowly, make small decisions in your personal life, and then start making them in your professional life. Any questions?
Thank you so much, Sofia. We can, I would suggest, if people have questions, maybe if you could remember them, and and bring them all forward at our little panel discussion later, which would be great to have a bit of a run around with that. So, Sofia, thank you so much for being here. I know you're sort of really busy in your internship at the moment, and you're doing this after work. So, really, really great to have you. So, guys, final presenter today, and we're absolutely delighted to have her as part of the panel. It's Gott, MBE. She's the UK Head of Industry and Corporate Social Responsibility at WSP, a global consultant. And she is really, as she says there, really a real passion for transforming lives, and has been driving net zero operations and humanitarian development programs. And she's going to talk us a bit through about that today, and hopefully will also prompt many, many questions for you guys, which we can pick up in a little bit of a panel session after this. Claire, over to you.
Thanks very much. Afternoon or evening, everybody. Just a quick intro into me then. So my career has actually evolved from being a chartered civil engineer to leading multidisciplinary design teams on major infrastructure projects like High Speed 2. And I now lead WSP's industry business, which is a 100-strong team working across pharmaceuticals, biotechnology, life sciences, gas networks and hydrogen, and also the chemicals sector. But I'm also very passionate about making positive, sustainable change, and that's reflected in my role as UK Head of Corporate Social Responsibility at WSP, and that's for our 7,000 UK employees. Next slide, please. So interesting themes this evening, because following on from Emma's presentation, it was actually humanitarian aid that attracted me to engineering in the first instance. I wanted a career where I could make a difference. It was as simple as that. And so in my final year at university, I co-founded independent engineering charity Cameroon Catalyst, which aims to facilitate sustainable development in rural Cameroon. And in the 10 years that the charity's been going, we've delivered a medical centre, a school, solar power, micro business facilities, and most recently, clean water solutions for over 20,000 villagers. And our engineering designs are quite literally transforming the quality of life and even saving lives. And in the 10 years that we've been out in Cameroon, we've halved the child mortality rate in the villages we've been working in. We've quadrupled the number of children attending school, and we've introduced 6 drinking wells. But this personal passion for transforming lives has, fortunately for me, very much extended into my day job. Next slide, please. We've all experienced firsthand through the current pandemic that pharma is a rapidly developing sector. And at WSP, we were part of the COVID-19 Lighthouse laboratory testing service at Bracknell. So as engineers, we're responsible for transforming exciting science discoveries into reality by delivering rapid design and build solutions that are both cost effective and environmentally friendly. But aside from developing vaccines, engineers are also responsible for tackling many of today's global challenges, from stem cell and gene therapies all the way through to curing blindness. But our biggest challenge as engineers is really designing for flexibility, being ready for the future. We have to accommodate the new technology through the entire life cycle of the project, whether that's from site master planning all the way through to the operation of these facilities. And so collaboration as engineers is crucial across the different disciplines and with the very many different professionals involved in these types of projects, whether that's utilities, highways, environmental, structures, fire, and the list goes on. Next slide, please. Another area where engineers are helping save the world is through our net zero carbon commitments, quite literally. That commitment in the UK is by 2050, and at WSP we've committed to halve the carbon footprint of all of our designs and advice by 2030 to make sure we are ready for that big ambitious goal. And it's very clear that hydrogen will play a really significant role in addressing the world's climate emergency. And that's because it's got the potential to decarbonise our domestic heating, heavy transport, and also our industrial sectors. And that's why it's so poignant for my role and my team. The key thing with hydrogen is we have the opportunity to use existing infrastructure. We can adapt what we already have and add where is necessary. But as we all know, hydrogen has a desperate public perception. And the key for us as engineers isn't just in the design, it's how we communicate what we're doing. And that is crucial in terms of trying to save the world. One example in hydrogen is at WSP, we are actually working on a hydrogen super hub in the port of Southampton. And that's to really prepare a feasibility study to investigate how we can decarbonise the industry and transport and create a centre of excellence for hydrogen production. So a really exciting project that's just the tip of the iceberg for this opportunity. Next slide, please. But it's not just about the big projects. I think we all recognise that as individuals, we have a responsibility to help reduce our own carbon footprint. And at WSP, we committed to become net zero in our UK operations by 2025. And we're on course to achieve that. But there are some challenges we've had to overcome. We've had to look at our business travel. If you take this year, for example, all travel stopped due to COVID, but we still didn't hit the 2030 target that's required. And so there's more that needs to be done. We need to be looking at our office performance. We need to be looking at how we use our offices, how we commute to work. And the hope is that actually COVID has helped transform that for us and helped accelerate what engineers need to do. So for me, I think it's actually a really exciting time to become an engineer, because the only way that we're going to tackle this net zero challenge and the other challenges that we're facing is by inviting you, young, talented professionals, to engage with experienced experts to bring fresh, innovative ideas forward and to bring them to life. Thank you.
Thank you so much to all of the speakers. It's a real pleasure and just a privilege to be together tonight and to have you on the panel. So I do think maybe if we go to our questions and answers session, and I'm sure many of you here will sort of digest all of this, but maybe if I get us kick-started so that everybody can start typing in some questions into the chat so we can take those off. But maybe if the panelists would unmute, and so then we can have a bit of a discussion. I think there are a couple of common strands coming through. And so one of the bits I wanted to sort of have your opinions on, actually, all three of you in sort of whatever order, is really about, you know, the engineer as part of a multidisciplinary team, you know, so really this challenge that is that is quite universal and needs all sorts of skills. But, you know, maybe Emma, starting with you, sort of in your work with Engineers Without Borders, you know, how do you see this multidisciplinary aspect?
Absolutely critical. When we're looking at a project, or we're looking at, say, you know, kind of as Claire was talking in terms of how a company can evolve, etc. I I think being able to look at it as a system is really key. And when we look at something like it at a system level, so whether you're looking at the political situation, the social situation, the environmental situation, kind of bringing in experts from different backgrounds, so social scientists, kind of business experts who can work out how this actually scales. When you're bringing in scientists and the rest of the kind of STEM field, the science, technology, engineering, mathematics field, I think there is a huge benefit, and actually something that's really unique at universities is when they can offer that interdisciplinary learning, because even how we communicate and language backgrounds and skill sets and assessing what type of language we use and what, like, it's all connected. So I think when we're dealing with problems that are in the real world, we need to bring in kind of experts and people to help advise on that and bring in different knowledge that's valued. And the final point, I think, is, you know, when we're doing projects that are trying to have an impact for people, is bringing in the perspective of people with that lived experience. So, you know, bringing in the real world understanding. I often used to think that hairdressers and taxi drivers might make better politicians because they have a really firm understanding of how the world works in a kind of real way. So kind of bringing in that lived experience as well of people who will be impacted by the engineering or may shape it to be much more successful in that real world system.
Thank you so much, Emma. I mean, Claire, if I go to you next, because I think you've sort of pointed out that WSP, the team you lead, is very interdisciplinary in this particular aspect. But, you know, could you maybe share a couple of experiences, exactly how this sort of manifests itself in a day-to-day and how a decision's made better by just bringing together the people and the energy that they bring and their backgrounds?
Yeah, absolutely. I mean, I think it's very easy to look at a project or look at work that's being done and assume it's, you know, a handful of people. I mean, if we take High Speed 2, for example, which is a major project, we had a team of over 200 engineers across 40 different disciplines, and that was just working on one of the stations. And ultimately, the only way that you get a holistic design solution is by considering all elements of the design and how they interact with one another. And the ultimate aspect for us as engineers is really to put ourselves in the shoes of the end user. So really, that's what's crucial about being an engineer and working with all of those different disciplines, is putting ourselves as the end user, thinking how we will use the space, how we will operate in those facilities. And the only way that we will really address a holistic design is by working together as a team, looking at the impacts of each decision that we make, and progressively working through that design development. So our projects simply aren't achievable without the full disciplines and the collaboration that we undertake.
Yeah, thank you so much for both of you. I mean, Sofia, you see where I might be going when I'm asking you this. You're sort of our most recent graduate at the moment, and I just really wanted to sort of hear your experience as to how much of an experience that has been for you, and how that feels when you're sort of going through some of the formative years at university, and also now that you've just started to have your first internship and some of the experiences you've gathered along the way. So how did that feel? Was that very multidisciplinary? Did you work with many other disciplines?
Yeah, especially with TEDI, and to build up on what Claire was saying, with TEDI, something that had never crossed my mind came up, which is we build for people. And when we're studying an engineering degree, at least from my perspective, we are completely cut off, and we only see that, and we forget, even if we're building a factory, the factory, we build it to make a product, and that product is for people. Who uses the machinery are people, and so ergonomics is another field that I've not come into contact with, like probably I've heard about it, and now that I'm working at a factory, it's something that has more recently come to mind, which is just the simple things, just the way people use their hands, put their hands. They can have a lot of problems, which I actually have no idea how to say in English, but like problems with their joints and stuff like that. And so I think it's key that we realize that as engineers, yes, we know math and we know physics, but the purpose, the reason why we're learning all that is to do something for people, for our planet. And when you realize that, everything will feel a lot better. And even those hard classes that you don't want to study, you will find a way to get through them and learn about it. And because you have an end goal, which is to help people, to build for them.
Oh, lovely. No, thank you so much, Sofia. Such points well made. So thank you so much. I have been really, brilliant. I have been asking into the group actually to have any comments, ideas, just whatever you want to post. It'd be great to hear from you. So we just have our first question in, and that is, what inspired you to become engineers? When did you realize it was something you wanted to do? So Emma, would you like to have a start with that?
Yes. So I was inspired by a poster in my school. So it was a poster that said, with a degree in engineering, here's all of the things that you can go on and do. And I quite like, I get bored easily. So I quite like the fact that it had a vast, like, a great variety of options. Yes, it is a skill set, but you can take that into different industries, into different companies, into different sectors, into you know, the not-for-profit world. And so it was that poster at in my school classroom that triggered it, and then the reinforcement when I said I was thinking about that, and people saying that sounds like a good idea.
When your nan saying, don't save the world. Yeah, but do whatever, just don't save the world. Brilliant.
Exactly.
Thank you, Emma. That's lovely. How about you, Claire?
I think I touched on it already, really,
Yeah.
but I knew that I wanted to do something that would make a difference. And I had actually been very fortunate. I'd fundraised to go out to Tanzania to climb Mount Kilimanjaro as a 16-year-old, but at the same time we helped rebuild an orphanage. And actually that's what inspired me. That was my eureka moment. It was very simple engineering. We were merely making bunk beds for these orphans. And actually, I just knew from that moment that I wanted to do something practical, hands-on, that I could see would make a difference. So I think we all get inspired in slightly different ways, but the end goal still seems to be that we want to make a difference.
That's so true. That's so true. Sofia, I think we've heard from you. Engineering is something that was on your mind quite quickly. And so we have a follow-on question around women in engineering as well. And so any thoughts you have on that? How do you, any comments?
I had my aunt, and she is an engineer. So she was my first contact with women in engineering. My degree had only 12 girls and 90 students. So yeah, but I always say, not to dissuade anybody from joining engineering, that we're treated like princesses because everybody knows our names. And so it's actually, I feel privileged. But I think tips to go into engineering, just be sure of yourself. You're always going to find people who will be hard on you, but it's not because you're a woman or because you're a man, but they might be hard on you. In my experience, I've never suffered from any sort of machist comments from professors or any of that, or even in all my internships, even in older people in their 60s who have worked their whole life, since they were 10, welders or plumbers or electricians. Just be open, listen to them, because they might seem rough on the outside, but you will find your way.
Yeah, and I mean, one comment from me, a very similar story to everybody here today speaking, but the only thing I'd say is, engineering needs diversity, and it needs diversity of thought and diversity of talent, and so it really it needs all of you. So and it needs you to have your voice, and to make your voice heard, and to engage and interact and find yourselves ways in doing that, and training as best as you can for it. So multidisciplinary work like this, or the work that we do at TEDI-London, is really helpful in that respect. So it'd be great to sort of move this on and have the next generation come through as you guys. So really, I have another one, which I think is a really tough question. So I'll open up to see who wants to talk about it first. So this is from Ruby. She says, you know, the climate, so from an engineer's point of view, do you think that it will be possible to hit the climate targets, and how hard do you think it will be? Claire's going first.
Yeah, I'm happy to start that one. Well, I mean, I think I've touched on what we've done as a business, and I think everybody's taking their own angle on this, but ultimately it's being led by governments and governments globally. And in the UK, actually, the latest announcement has been that carbon emissions will be cut by 78% by 2035 compared with 1990 levels. So I think that should give us some real confidence in the difference that we have been making. And we've also got the US back on board as well, with committing to their reductions, which is really positive. But ultimately, as I said, I think the only way we're going to make that final hurdle is if we collaborate better and actually bring down the barriers around competitiveness in terms of research and development. We've got to come together really as a society to drive that forward. So the commitment's there, the legislation is there. I think it's taking it one step beyond that to make sure we hit those targets. Yeah.
Yeah, brilliant, Claire. Is there any other comments from the other panelists on this, Emma? Yeah, you next.
I potentially have a slightly different view on that question. So I think that, so the question is, do you think it would be possible to hit the climate targets, and how hard do you think it would be? I think it is possible. I personally am an optimist, so I think it's important that we recognise that human beings are inventive. We have tackled huge problems in the past. We have, you know, generated innovation repeatedly. So we're not just like doing one thing. We have that creative ability to solve problems, and we can see from, you know, the vaccine development and then rollout and the speed that happened compared to the past. Like, we have the innovative ability to respond to a need. I think it's complex, the carbon targets and the greenhouse gas emissions and the kind of complexity around that, because it's a system. It's not, we can't just do carbon. We have to be thinking about biodiversity. We have to be thinking about the social foundation of all people and the sustainable development goals and how they interlink. So it is complex. And I think for me, it will take a shift in engineering. It will take completely the strategies to make that happen and the leadership to make that happen. But fundamentally, it will come down to the people. So if we just think about the role of engineering in this, the people within engineering to respond. A survey that came out in February this year said that, and it was by the Institution of Engineering and Technology, so the IET, said that when they interviewed engineering business leaders, 93% of those that have a sustainability, 93% of those that have a sustainability strategy do not think that their workforce has the skills to meet that, which I think for me sparks that there's mindset change and attitude change and skill sets and mass upskilling within our industry to be able to respond to the need. So I think in terms of how hard it will be, we need to get to a tipping point where we are, you know, thinking about what is the skill sets that are required and upskilling people in that and driving change, and looking at the fact that when we look at, you know, the IPCC's graph on emissions and what the 2 degree or the 1.5 degree pathways look like, the graph goes up, and it's not flattening the curve, it is dropping that curve so dramatically that it's not even a flattening process, it just drops. So for us to achieve that, it's going to be quite a lot to get to that tipping point towards one of those pathways. And it's complex, it's a global issue. And I think it will involve kind of a movement towards creating that change, and progressive leadership by businesses and governments. And the UK is, you know, positioning itself to be a leader in the kind of green economy. And I think that I have hope, but I think I think we shouldn't be too naive about the fact that actually there's a huge cultural and skills piece here to make sure that actually can be achieved, and kind of a challenging each other on, you know, doing better and kind of learning and challenging as we go, a little bit like Sofia described the kind of learning journey she had. Is, you know, we have to kind of be a little bit more humble and think that there's this huge learning journey for everybody within engineering to kind of to be able to make that change.
Yeah, thank you. And I think it also picks up on the next question we've got in the chat, which is all about what's the best engineering discipline for sustainability. And I think between us and everybody on the call as well, again, I'm going to go to Sofia quickly on that, because again, she spoke about that specifically. But for me, it's actually a very multidisciplinary challenge that needs to be tackled in that way. So I think there are many facets to this, and I think all of them are important, and I think they need to work in collaboration. It's not just technology, and it's not just, it's a combination of all of them. And I guess Sofia has made the point really eloquently, actually in our own talk. But you know, you have covered many, although you studied one particular part of engineering.
I think there's no particular discipline, but something like the TEDI-London summer school program, something, or just challenging yourself, you know, talk to a group of friends and challenge yourself, because when you have a problem and you try to solve a problem, there are going to be plenty of questions, and having a problem is the best way to study sustainability, because when you're creating something, you have to have these aspects. Even in your own home, each time that you make a decision about something new that you want to incorporate, you're buying a new fridge, you're buying a washing machine, are you gonna pay more money to have a lower energy consumption, or are you gonna pay less? You know, there are certain things that you come across in life that will, you know, sustainability will come up. And so the best way is to find a problem and try to solve it. And for certain, you'll find a way to study sustainability.
Absolutely, Sofia, thank you so much. And I guess it speaks perfectly to the TEDI-London concept, really, where we really use project-based study as the center and focal point to sort of really progress the learning and the skills that we need for tackling real world problems with real world tools and with multidisciplinary engineering disciplines around us. So thank you so much. I mean, I think there is a slight question there in a bit more detail, which we're very happy to pick up actually separately. So if you wanted to stay back to talk a bit more about TEDI, we'll be here after the panel if you wish. So we're really pleased and keen to hear from you and answer any questions you might have specifically. We've got one particular question around low carbon alternatives, electric cars, plant-based food, but what's sort of the biggest challenge in a changing culture? What about people? And I think that's a really good question. It's something that all of you have touched upon, but really about, you know, how do engineers interact with people, and how exactly do they lay the groundwork for some of those changed habits? I mean, Claire, would you have a comment on that?
Yeah, I think there's two angles to this. I think, you know, firstly, at WSP in particular, we haven't shied away from the fact that actually we need to shift the culture of our people to be able to make a difference on the projects that we're working on and also our own operations. So we can't look at what we're doing at work in isolation. We need to bring it into our everyday lives. So I think there's that element really, and all organizations I think have a responsibility on that front. But I think the other angle is more akin to society. And I touched on it earlier, but in terms of hydrogen, I think there's a lot of perceptions around these solutions that are being proposed, and a lot of them aren't being welcomed, you know, very much not in my backyard type approach. And I think unless we communicate effectively as engineers, we will struggle to bring society on board to create that culture shift. So for me, engineers, we're very good technically, but actually communication and the softer skills are so critical for us to make this culture shift.
Yeah, no, you see us all vigorously nodding. Thank you, Claire, for putting this so eloquently and so aptly. I guess, yeah, just we're sort of 4 minutes to go. So really just a short comment on those from Sofia and Emma. And then I think we'll have a quick fire round to say what engineering discipline all of us are before we close. So Emma, Sofia, just quickly around, what do you think people, culture, engineers, impacts? Agree
with everything that Claire just said there. I would say that just as a a signpost to something really interesting is the UK fires. So it's Cambridge University and Bath as well, I think. But a group of kind of engineers have come together to look at that roadmap for, if this is the target around emissions, how do we get there? And there's some pretty stark, like it's that beautiful engineering logic that's like, this is how we could do it. So UK fires and absolute zero. There's a great YouTube video with Professor Julian Allwood explaining that path, kind of talking about what is the role of new technologies and existing technologies and what does the societal shift need to be as well. So just pointing at that. It's a 25-minute YouTube video, well worth a watch.
Super, thank you. Sophia?
I don't really have anything to add. I'll just say that it's really hard to change cultures, and maybe the world isn't ready to change cultures in a heartbeat, but the planet needs us to be. But we need to be tolerant and realize that maybe some of us who are ready to do more should do more to balance out the ones that aren't ready to.
Yeah, and studying engineering is one big contribution by the sound of things that will make that happen. So quick fire round, engineering disciplines from the panel. Sophia, I think we know yours, so just quickly.
Mechanical engineering.
Mechanical, and Emma.
I'm a chartered civil engineer, but also an engineer without border.
Very
without
good.
sounding too cheesy.
Very good. And Claire?
I studied two, actually. I studied civil engineering, so I'm a chartered civil engineer, but I also did my part 1 in architecture, so bringing home the multidisciplinary importance.
Excellent. And I'm a structural engineer by training. So it is really, really great. I just want to sort of say thank you in these last final minutes of our time together to our great panel. I hope you all agree. There's been outstanding speakers and your time is so appreciated. So thank you so much for making the time and your great insights and just the passion and the energy and just a great project. Absolutely brilliant. So thank you so much for that. And really, thank you guys for coming, you, the audience. Really, really great to have you here. Loved Emma's quick fire round, so that'd be great. We can't wait to read all of those again. I think it was a brilliant exercise and shows how much you guys are there. And yeah, please, I'm happy to stay back a little bit if you've got any questions about TEDI-London. We'll be here for a couple of minutes longer if you wanted to ask any questions you have. So yes, you guys, thank you so much. I shall leave the panel to sort of get on with the rest of the evening, and thank you again for your time. It's been brilliant. Thank you, guys.